So in this video, let's understand operations on surds. So when I say surds, those are irrational numbers such as root 3, root 5, root 7, root 11, root 13, most of them irrational numbers which are non-terminating and non-recurring. So we'll try to understand addition and subtraction in this, and the next video I'll try multiplication and division and different things that you need to keep in mind. But I've seen that many students they struggle with adding and subtracting. I don't know why. It's very simple. What I'll do is in this video I'll try to compare this with the algebraic expressions, additions and subtraction, so at least you get to know what it actually means. So what I'm going to do here is on the right hand side, and this will be algebraic expression, addition, subtraction. I'll try to compare this with my operation of these irrational numbers. So let's just take algebraic expression. What do we do? Let's just take, before that let's understand two things. For addition and subtraction we look for like terms. So when I say like terms, let's say if I write it as 2x plus 5x square minus 5x, the variable with the power in that particular term should be same. Here power is 1, variable is also same, so that means these two are like terms. If they are like terms, I am able to add and subtract. What am I able to add and subtract? The coefficients here. So because they are numerical coefficients, I can actually perform integer operations, which is 2 minus 5, and then that will be x, which is minus 3x. See the way I have written here, I could have done 2 minus 5 is minus 3x. Yeah, that we can do, but you have to keep in mind the way I have done is, if I take x common, 2 will be left here and minus is there and 5 is also there, exactly same thing. So minus, this is integer operation, that's my variable, because those two terms were like terms. X square, x variable is there but the power is different, so that's unlike term. Let's come back to operation on surds. So if I take root 3 plus root 5 minus 4 root 3, now you had to see under the root the number. Here this and this are same, so you have to remember when I say this is radical, whatever is under is radicand, and here 2, 3, cube root, 4th root, 5th root, these are all index. So my radical and index should be same, and the number radicand should be same. All of them should be same, because I cannot add square root of 3 plus cube root of 3, because my index is different compared to this. Nothing is there, it's 2, so I cannot add them. That's why I can't call them as like surds. So I am going to look out for like surds. Here root 3, if I take it as x, again root 3 if I take it as x, this is what it's going to look like. Root 5 is entirely different, although radical is same but radicand is different. I cannot consider them as like surds. I can consider these two as like surds. If it is x, this is actually 1x. Now x is representing root 3. If I take root 3 common, what will be left here? 1, and here minus 4 is left. This is actually going to give me minus 3 root 3. If it was algebraic expression, I would have written as minus 3x. So you have to keep in mind, the only thing, the condition is the index, radical and radicand should be same. This I can't add these ones. I cannot add 5th root 5 plus 2 root 5, because my radical here and here with the index is different, but whereas radicand is same, but they don't make it as like surds. So the things that what we learned here is addition and subtraction. If it is 5 root 7 plus 6 root 7, root 7, if I consider that as x, or even if I take this as common 7, 5 is left plus 6 is left. Always take with the sign. 5 plus 6 is 11 root 7. So the things to remember for addition, subtraction, mainly considering in terms of operations on surds, comparing with algebraic expression, both of them are same. There we talk about like terms, here we talk about like surds. And surds, when I say like surds, the root radical, radicand and index are same, only then I can add the number outside. Remember this, one more thing here, nothing is there, it's always 1. Similarly, same thing here, if it was x plus 4x, this is actually treated as 1x, which is going to be 5x, again based on like terms. So like terms, like surds. Operation is integer operation, and then put the same surd on the right hand side, you will get either sum or the subtraction, but make sure that this operation is integer operation. When I say integer operation, it has to be with the sign. So I hope you actually understood this particular concept. If not, there is simplification in terms of addition, subtraction. Let's just see. When I say simplification, let's take root 3 plus root 12. So if I am actually adding, I can see that actually my index and radical is same. Radicand is not same, so you can't say that you cannot add until and unless you simplify the roots. When I say simplify roots, try to prime factorize and simplify it in such a way that the last number which is under the root or which is under the radical is not going to be simplifiable anymore. So root 3 I can't do anything because it's already a prime number. So root 3 I'm going to keep it as is. Root 12 prime factorize, if I do 2 6 2 3 3 1. So this is actually going to be 2 2's, which is 2 square, and one more 3 is left. I have written 12 as 2 square into 3. 2 square, square root of 2 square is 2, so 2 will come out and root 3 will stay as is, and I will have root 3. Now this is treated as 1. Now it looks like both of them are like surds. I can add them. 1 plus 2 is 3 and root 3 is root 3. I have given a smaller number. You can have 196, 625, any other number, so you can still do it. So make sure that when you try to find perform operations on surds, mainly addition and subtraction in this case, make sure that you simplify, then look for like surds, then add or subtract. So I hope you got an idea exactly comparing with the algebraic expression. You should not have any doubts. If you have any doubts, just put it in the comment below. I'll see you next time with multiplication and the division.